Hello and welcome to the class. Good evening. Everything is clear. Sound and video board. Today we start Unit 2, a new topic, a new unit. Unit 1 is covered up and I already sent the notes. Start to read. Unit 2. Unit 2 is milk-based fermented food. Milk-based fermented food, which is the topic name. And under this topic, under this unit, we first read starter culture. Starter culture. That is our today's topic. Starter culture under milk-based fermented food unit 2. Here, let's begin the class with the interesting question. Try to answer. Can we make fermented food without fermentation? A tricky question, an interesting question. Can we make fermented food without fermentation?
বেসিক্যালি না, কিন্তু আপনি কি এরকম বলছেন যে যদি আমরা কেমিক্যালি বা পদ্ধতিগতভাবে না করি, যদি ধরুন দুধকে আমি রেখে দিচ্ছি, এবার দুধটা যদি খেতে যায় তো বেসিক্যালি নর্মালি হবে না, আমরা কিছু অ্যাপ্রোচ করছি।
সেখানে তো মাইক্রোবস এর হেল্প নিচ্ছ। Without fermentation means what? Without the need of microbes, the fermented foods can be produced. Is it possible? Rest of them in the online. Those are in the online. Is it possible to make fermented food without fermentation? Think twice before answer.
No, sir.
Okay, no. See, without fermentation means without microbial help. Other than Janhavi.
No, sir,
Answer
it's not.
yes or no. Monomon. Answer no. Maximum answer is no. That means we cannot produce. No. The answer is yes. It is some food products can produce without fermentation also. That's why I repeat, think twice before answer. Without microbial help. By means of chemicals. Let's read some example. Yes. Answer is yes. Fermented food can be produced without fermentation. Interestingly. How? Let's see. Example number 1. Cottage cheese. What is cottage cheese? Basically the paneer. During paneer making in home, do you think the culture is added? So what you add? Just a acid. Just a acid is a citric acid. You can use the raw lemon also. Yes or no? So cottage cheese is a fermented food product, but we can produce it without fermentation just by addition of Simple food grade acid. Yes, also food grade. You cannot use nitric acid or sulfuric acid for the cheese making, cottage cheese making. That means paneer. Paneer making is a food grade acid we can use to make cottage cheese, and cottage cheese is the fermented product. Ultimately, fermented product is a cottage cheese, but we can make it without fermentation. So that's the interesting question. And answer is yes. The cottage cheese, how can we make without fermentation? We can easily make. We can make it by addition of food grade acidulant. Mainly we use lactic acid or citric acid. Yes or no?
Yes.
Second example. Carbon dioxide can also be produced for making breads or bakery product without fermentation. Carbon dioxide actually come from the fermentation by means of yeast. When yeast start to utilize the sugar, it produce ethanol and carbon dioxide, and this carbon dioxide we are using in the bakery industry to make breads and etc things. Clear? So this carbon dioxide we can produce without yeast also. Without yeast also. Can you give example how it can be produced without yeast? By simply using baking soda. Baking powder is the alternatives of the yeast, yes or no? During our dough making, we use baking soda, baking powder, and baking powder in the low pH and the heat, they start to produce carbon dioxide. The same byproduct that produced by the yeast, the same product, carbon dioxide also produced by some chemicals. Huh? So CO2 can also be produced in the bakery product without fermentation. How? By addition of, they are called leavening agent. Leavening agent. Leavening agent means that produce gases. Like
So, what is leavening agent?
produces gas after reaction. Like baking soda, baking powder. Nowadays, example number 3, this soya sauce production also it produce chemical in laboratory. But soya sauce is a complex fermentation product of the vegetable soybean. But nowadays, the soya sauce produced chemically in laboratory, as well as the vinegar. Vinegar also produced chemically by means of simple chemical reaction, not by the fermented. Clear? So soy sauce, vinegar, that means acetic acid, can also be produced chemically in laboratory scale by simple reaction. So my question was that is it possible to produce without fermentation? It can. And some example. But these types of product which produce chemically or by some acid addition, the quality is varied from the microbe based fermentation or not?
Yes.
My question is clear. Second question: is these products and the microbe based original fermented product, the quality between these two products is varied or is it equal?
Yeah.
Monomai বলছে yes, it will vary. বাকিরা, rest of them, this type of product an original fermented product that created by the microbes, seasoned product, that means need more time.
Yes.
So these two products can vary in their quality or in their texture or they are same basically. Do
So
you
they
think the
vary.
vinegar that came chemical means and the vinegar that came from the biological means, that means proper fermentation, these two products quality will be differ or is it same?
So the flavor is different.
So clearly difference. That's why the chemical means production of vinegar, the bottle come just 30 rupees.
Yes.
Just 30 rupees or 20, 20, 20 to 30 hardly. Clear? But the seasoned product, seasoned vinegar, fermented vinegar, just only 500 ml, it will be priced around 150 to 200. Why?
It takes time.
It takes time to season. They actually, this type of product, that means chemical based fermentation product, it needs less time to produce and it produce more and do not needs any expertise or anything some knowledge. Just add the acid, anything acid, and card will be produced. Yes or no?
Yes.
But in fermentation, in case of scenario of fermentation, there strict some measures are done. Previous last day we are discussing about that how the change occurred from the traditional to modern food factory, food industry, fermented food industry. Now we are more concerned about the food safety, and there will be when the fermentation occur, other microbes can also start to spoil. So there are a variety of knowledge you should gain before fermentation, real fermentation with bacteria. Clear? And it takes more time. It takes to season more time. That's why the price also increase. So clearly the statement number two, the chemical based fermented product and the microbial fermented product, these two products are different. There should be variation from microbes fermented food and chemical based fermented food. Yes or no? The statement is correct or false? This statement is 100% correct. 100% correct because micro fermented food and the chemical based fermented food, the main difference, ultimate end product could be the same, but the main difference will organoleptic property. Organoleptic properties. The main difference lies in organoleptic properties. It is discussed, this term is discussed in last class, organoleptic property. What does it mean? Organoleptic property, taste, flavor and texture. Food taste, food flavor and food texture. These three properties is the organoleptic that make better appearance, better consumable, better taste of the fermented product. So organoleptic properties are the main three things: taste, flavor, and texture. So microbe-based fermented food always high in organoleptic property. Yes or no? Microbes-based fermented food are always high in organoleptic property. So that means better taste, better flavor, better texture, better appearance than non-fermented chemical-based fermented food. Clear? And my question is how microbes increase the organoleptic property, and that failed to do by the chemical based fermented food. What is the lacunae? What is the lacunae behind the chemical based fermented food that cannot enrich the organoleptic property, but the microbe based fermented food has enriched organoleptic properties?
মাইক্রোস অরিজিনালি ফুড অর্গানিক মানে অরিজিনালি প্রোডাক্ট করে আর কি।
করলো
যেরকম সাধারণত আমরা দেখি সবজির ক্ষেত্রে দেখি যেগুলোকে আমরা সাধারণত বছর করে টাইম দিয়ে ফলে সেগুলো কোয়ালিটি অলওয়েজ বেটার থাকে, আর যেগুলোকে আমরা কেমিক্যাল ইউজ করি ওর টাইমটাকে আমরা অর্থাৎ যেটা দরকার পর্যাপ্ত সময় তার থেকে তাকে আগে কম কম সময় দিয়ে আমরা ওটাকে তাড়াতাড়ি মানে ব্যবসায়িক উদ্দেশ্য
মানে টাইম একটা ফ্যাক্টর বলছো। One factor is time. It's good point. It could be. Time is the factor behind the organoleptic property development. All agree? Because when you give the less time to ferment, less time to produce the ultimate the end product, there is less chance to produce organoleptic properties like taste, texture, and flavor. Another point, it is good point, good thought.
Fermented food is concentration of bioactive compounds.
chemical side effects.
Bioactive compounds. Bioactive compounds means other than fermented main basically main end products,
Yes.
right? Good. That is also another point. That's 2 points are very important. One is time. Why microbe-based fermented food are always high in organoleptic property? The reason behind number one, we give proper optimum time to ferment the product. But in chemical based, we try to achieve it more faster, more rapid because of the yielding issue. Clear? Time issue. So one of the factor is time, and another important point is other products that form after fermentation. Just think one time when you ferment the milk as a required amount of time by suitable microbes, suitable fermented dairy-based microbes, you only found the lactic acid in the milk or found other compound also. Not only the lactic acid, you also found some amount of acetic acid, some amount of acetyl CoA. Various kinds of products are still there, but they are in the less concentration, less quantity. The major quantity is the lactic acid, that's for sure. But the other products makes the milk or makes the fermented food product is better, enhance the texture, enhance the flavor, and actually enrich the totally organoleptic properties, right? But when you add acid into the milk, just you add acid and the casein protein, the milk contain the casein protein, and casein protein start to coagulate to form the cottage cheese or paneer. No other products are there. No other products are there after you add the acid. Only the acids are there, and that make the protein coagulation. But if same thing are done by the microbes, not only the lactic acid, other compounds also there, but they are in the less concentration, but still there, and that make the product more flavorful. So second point is very important. One of the reason is time, and the second one, when microbes are ferment the milk product or anything fermented microbe-based fermented product contain the optimal amount of end product as well as other products also, and that enrich the flavor, that enrich the taste, which is cannot given by a single chemical reaction by laboratory. You can make soya sauce, you can make as the vinegar, but the taste is totally different. The taste flavor, many way it can differ. Clear?
আর স্যার যে সাথে হেলথ ইস্যুস যেটা যদি আমরা সাধারণত
That's very clear. Chemical based products is potential problem because it use direct acid, direct NOH can be acid, can be used. So various direct chemicals are used that create problem, health issue, health injury. Not in shorter term, but in longer phase. In shorter term, you cannot observe anything problem that happen after consume the acetic acid or after consume the soya sauce. But in longer case, it will create some problem. But the microbes based product is totally harmless if it creating proper environment, maintain proper environment during the fermentation. Clear? So clearly the winner is from the fermented microbe based fermented food and the chemical based fermented food. The winner always microbe based fermented food because it achieves more organoleptic property. So third point came from the review. Microbes based fermented food is best. So next question is, how does microbes use to ferment food industry? How does we clearly see that microbe-based fermented foods are best, and we try to achieve by the microbial fermentation. So how does we can use microbes to ferment food in industry? For the microbe-based fermentation, we need microbes, a source of microbes. So a particular source, particular type, and particular amount of microbes are needed to start the fermentation process. And in industry level, how it can achieve? Think
অ্যাসিড লেভেল কিভাবে পাবেন
industry level.
মানে সাধারণত মাইক্রোবস যেটা আমরা করি
তো আমার তো পার্টিকুলার মাইক্রোবস দরকার, তো পার্টিকুলার মাইক্রোবস আমি পাবো কোথা থেকে? So how industry run by means of food industry run, fermented food industry run to make fermentation optimum fermentation? It can be in three ways. We can use the microbes in three ways. Number one, rely on indigenous microbes. What is indigenous microbes? Fast process relies on indigenous microbes. The fermentations can proceed by means of number one, indigenous microbes. Indigenous microbes mean the microbes usually naturally present on the raw product. That means milk contains certain amount of bacteria, certain amount of yeast and mold. It's naturally present. Vegetables contain some bacteria naturally. So that natural organism found in the food products, they are called indigenous microbes. So we can rely on that. So indigenous microbes can ferment the product. So that's the first way to start micro fermentation. So indigenous microbes means microbes that found naturally within the food and vegetables. So we can start the fermentation by using indigenous microbes. But what is the disadvantage of this method?
Basically, we cannot produce it actively.
We can, because it is so indigenous. We do not use externally, just present in the food products, and they start to create fermentation. But other potential disadvantage there to use indigenous microbes. Try to guess what can be the problem to use indigenous microbes to start fermentation. What will be the issues? Try. What will be the problem to use indigenous microbes to start fermentation? See, indigenous microbes means microbes present in the food products or vegetables. Only the fermentation causing microbes are there, or spoilage causing, disease causing, all types of microbes are there in that food. Yes or no? We are relying on the method that is microbes present in the foods or vegetables. So only fermentation causing microbes are there in that food. Variety of microbes are there, not only the fermentation causing. Some microbes can spoil, some microbes can cause disease. Yes or no? So after fermented product, can you blindly consume that products? After indigenous fermentation, indigenous microbes used to ferment the product, are you sure the it meets the guideline? It meets the safety? It meets the quality? It cannot, because we are relying on the indigenous microbes. Those microbes, which that microbes could be anything. Yes, yes or no? So when we change from the traditional to modern, we are more particular about the safety level. So disadvantage number one is it safe to consume? you you are not guaranteed about that it is safety, because variety of microbes present in the food or vegetables, and that make some poison, some toxin. Yes, fermentation also happen, but some toxin also should be there. Nobody can guarantee you. Yes or no? My point is clear or not? So disadvantage number one, no guarantee that these products meet quality. That is also a problem. No consistent quality can be produced all time. Sometimes it will be better, sometimes it will be less. It's actually happening, it is naturally, no? So the quality that we make the standardized quality, it cannot meet all the time if you use the indigenous microbes. Yes or no? So it does not guarantee about to meet the standardized quality, safe to consume or not. That is the biggest disadvantage. But it can be one of the way to start fermentation, and probably it is the oldest way, because ancient time there is no knowledge about the microbes, so they are particularly used for relies on the indigenous microbes only. So it is the oldest way, but there are potential disadvantage also. This method is the oldest method to start fermentation. Point one clear.
Yes.
Those are all nice. Answer clear.
Yes.
Yes, sir.
Yes, sir.
Okay. Point number two. To start fermentation, this is another process, back sloping. Back sloping, not black, back, BSK, sloping. Favorite question, what is back sloping in fermented food product? Back sloping means when a particular products are formed after using indigenous microbes, a well fermented products are formed. Clear? Successfully produced. You are testing that product and it is successfully produced after using indigenous microbes. It can, okay. So take that, maintain that amount of a small amount of that fermented product, that fermented food, and that is used for the second batch, and it is called back sloping. That means when you start to produce curd, in the fresh curd, you just add 1 teaspoonful of previously made curd. Yes or no?
Yes.
So that's the method is back sloping. So once the successful fermented food products are produced, required amount of or just use small amount of fermented product to store, and it is used for the further fermentation, because it is already fermented and already required amount of microbes are there in previously fermented food. That's why the second batch is automatically fermented. So it is quite easy, and backsloping, modernized technique that also used in the industry. Backsloping. It means if proper fermented food, proper fermentation occurred, a portion of product kept to store and add to the next batch of fermentation. See the definition. A proper fermented product previously successfully produced, and that fermented products, a portion is kept. A portion of this product is kept to store, and these portion are used for the next batch fermentation. Just like curd making. Example, backsloping, commonly used in the dairy fermentation. For example, curd making. So after curd produced properly, curd produced, a small amount of curd is kept for next batch. To next batch to ferment another round of curd production. So that's concept of backsloping. Already produced. Just small amount kept that hold, and that used for the next batch to ferment. Because that product contain required amount of microbes. Same problem. Same problem, because you not cannot guarantee about the quality, because that fermentation, the fast fermentation, that is also used in indigenous method, indigenous microbes. So same problems appear, that it cannot meet the standardized quality. So third and well maintained or best method to start fermentation is use of starter culture. That is our topic heading, starter culture. Use of starter culture. In this case, a pure culture of desired or relevant microbes type and number can be used. Look the description of the third method. A pure culture is used. Pure culture is used. Pure culture means only that microbes is there in that culture, only that microbes, that strain, not the mixture of strain. That strains or that microbes that we want to add, that is the pure culture. But in this previous two case, just see that indigenous microbes are backsloping. Different category of microbes present. It could be fermented microbes or also spoilage, or different variety of microbes are there. But here, in the case of starter culture, only desired microbes. A pure culture is produced, and that contains only desired or relevant. Those microbes are actually involved in the fermentation. That relevant microbes are produced to make starter culture. And not only the type, and also the certain quantity also important. Certain number of microbes are used to start a fermentation process, that is well tested. So before fermentation run, a pilot experiment, variety of pilot experiment should be done. That means how many microbes should add at the first. So that is another criteria. And what types of microbes you are going to add in the fermentation, that is properly tested before, and make a pure culture of that solution, and it is your starter culture. And this starter culture is way to go because it meets the standardized process, it is safe to consume, and etc. Variety of desired changes can be produced, which is failed to do that by the previous two methods. Clear? So when starter culture is inoculated, then desired change occur in the finished product. Yes or no? When starter culture is inoculated, desired change occur in the finished product because we are previously tested which cultures we are going to use in the fermentation and what number it is used. Number is also important. Less than optimal number and more than optimal number make the product less attractive. Clear? So desired changes made when you add the starter culture. So what are the desired changes? Number one, starter culture make the finished product novel functionality, make the finished product reduced food safety risk, make the finished product improved nutritional value, make the finished product to reduce the spoilage, and increase the shelf life. Isn't it? This type of desired changes should done by a good starter culture, which is absolutely necessary now in the modern industry. Shelf life increase, improve nutritional value, reduce food safety risk, and functionality. So, which method is best? Clear. Which method is best? Clearly, the use of starter culture in fermentation process. The use of starter culture of fermentation process. Because starter culture contain required amount, optimal amount, and relevant microbes that actually change the product into good fermented product. Done. Clear. Starter culture types. These points are clear. What are the changes created by the starter culture?
Yes, sir.
Okay. Starter culture types. Types of starter culture. Single starter culture, multiple starter culture. Single means just one type of particular microbes are added to make the starter culture. So in single starter culture, one well-defined strain used. One well-defined microbial strains used. Microbial strain used. Single starter culture used in dairy fermentation. Lab lactic acid bacteria is a single starter culture that used in the dairy fermentation. Yeast single starter culture used in brewing industry, baking industry. So one particular strain or one group of strain is enough to make well-defined fermented food. That starter culture is called single. Just single is enough. Single type is enough. What about multiple? Clearly name suggested more than one desired types of or relevant microbes groups are must be present, otherwise the actual fermented food products not produced. That time we are using multiple strain. Usually 2 to 6 well defined strains, microbial strains are used. Multiple starter culture used in meat based fermentation. That means sausage making, vegetable based fermentation needs multiple strain, where single strain is not enough. So starter culture based on the number of strains we are using, it could be single, it could be multiple. Types of starter culture clear. Next topic, starter culture microbes. What are the microbes used in starter culture? Starter culture microorganism. Starter culture microorganisms. We can use bacteria, yeast, or mold for starter culture microbes to start the fermentation. Bacteria as a starter culture microbes, yeast or molds. Bacteria, under bacteria, the well-known starter culture bacteria is LAB, lactic acid bacteria. Some non-lab also can be used, non-lactic acid bacteria, but mostly used lactic acid bacteria. Lactic acid bacteria actually it consists of They are all gram positive, gram positive cocci or rods. Most labs start homolactic acid fermentation. Homolactic fermentation. Majority lab create homolactic fermentation in the product, but some can do also heterolactic. Examples of some lab: Lactobacillus, famous genus for any type in the food industry. Lactobacillus lactis, Lactobacillus cremoris, Lactobacillus bulgaricus, Lactobacillus casei, Lactobacillus plantarum, as well as leuconostoc, lacti, and leuconostoc mesenteroids. They all are in under lactic acid bacteria. Majority, we are saying that majority are the homolactic from the Lactobacillus lactis to Lactobacillus plantarum. They are all homolactic fermentation. They create homolactic fermentation. But leuconostoc, these two group, this genus, leuconostoc can do heterolactic also. So that's why it can be done both homolactic as well as some can create heterolactic fermentations. Some non-lactic acid bacteria, example, Brevibacterium, linens, used in cheese pigmentation, used in cheese to create surface pigmentation. Propionibacterium shermani, this is also used to make hole, large eye on the cheese, Swiss cheese making. Large eyes are created. Staphylococcus carnosus, used in meat fermentation. So clearly, we can use to starter for the starter culture making bacteria. Majority we are using lactic acid bacteria, and some examples are there. Variety examples have in the lab group, and some non-lactic acid bacteria also we are using to make associated product like cheese pigmentation, cheese whole, etc., etc. And the meat fermentation directly we are using staphylococcus.
Sir, could you repeat the last one?
Staphylococcus carnosus, Carnosus. It used in the meat fermentation. Yeast, another potential microbes that create starter culture. Saccharomyces cerevisiae, one of the favorite base yeast. Saccharomyces pastorinus. Saccharomyces cerevisiae used in both bakery and brewing. Saccharomyces pastorinus, this is also used in brewing, beer production. Mold, Penicillium, Roquefort, cheese making, Penicillium chrysogenum, sausage, meat-based fermented product, sausage making, Aspergillus oryzae, important mold, used in soy sauce making, Rhizopas, Oligosporus, used in tempeh production. Clear? Some starter cultures and their use in the industry. Starter culture microbes can be bacteria, yeast, and mold also.
Sir, in rhizopus, you have written it is used for.
Tempeh, TEMPH, vegetable based fermentation. And my next topic, how to make starter culture. Production of starter culture for industry. Clearly here in the example, starter culture contain maybe one or two or six microbes. So how this group of microbes are created, a pure culture is created in the industry scale. Start with the isolation. Isolate desired microbes. That means we want to start dairy fermentation. What we need? We need good quality of lactic acid bacteria, right? So first isolate lactic acid bacteria, particular bacteria. If we need Lactobacillus primordius or Lactobacillus lactis, so isolate particular desired lab and make stock culture. Stock culture means high concentration of that microbes. But we need particular amount of microbes. We have written previously particular microbes and relevant microbes. That is the concept of starter culture. But first we have to make high concentration. So that is the stock culture. Stock culture means it remains in the high concentration. Particular microbes remain in the after isolation. It created high concentration. And the next step will be confirm the purity. Important step. You isolate desired microbes and if it is mixed, then we cannot use it as a to start the fermentation. So first check the purity. Purity means it is mixed or not, mixed with the other microbes or not, is properly only one group of microbes or not, and second another purity checking, it is attacked by the bacteriophage or not, because bacteriophage, if the bacteriophage is previously attacked, then after fermentation no fermented products will be formed, because the bacteriophage will destroy all the microbes during the fermentation time. Yes or no? So confirm first the purity. Purity means check the pure culture or not. Number one, the isolated bacteria is pure culture. Second, confirmation is it is not attacked by the bacteriophage, because it's a tendency bacteriophage to create lysogenic phase inside the bacteria, and after when you introduce into the fermentation vessel, it created lytic and make all the bacteria to destroy. Then no fermented foods are produced. Total fermentation is collapsed. So after isolation, make the stock culture, then confirm the purity testing. After confirmation, propagate. Fast propagation done in the small volume. Small volume, because the pH also should be adjusted. Every microbe, we know optimal temperature is needed and optimum pH also needed. Every microbes grow at optimal pH. It could be acidic. Some microbes prefer acidic. Some microbes prefer neutral. Some microbes prefer alkaline condition. So first propagate in the small volume and then adjust the pH which is actually optimal for that microbes. So created the adjustment. So basic means of small volume propagation to adjust the pH. pH control. Now you optimize the pH of the particular microbes, then propagate in the large scale, large volume. Propagation means grow kora, just growing the microbes in an environment medium. Propagation. First we are done in the small volume, then in large volume. After propagation, packaged, freeze, and storage. That give you frozen bulk culture, that produce frozen bulk starter culture. And it is ready to use now. It is ready to use for fermentation, because already it is frozen. Just before fermentation technique, just remove from the piece, and after thawing it can be used. Clear?
Yes, sir.
So by that way the industrially starter culture are produced. If you want to store long purpose, that means this starter culture used in future experiment. That experiment could be 1 month, 2 months later, or it could be 1 year later. So what will you do? Just modify. After propagation in the large volume, we are concentrating the bacterial cell, concentrate, and concentrate done by the two process, either centrifugation is a gravity based process, rotational process, or filtration. By that way we can concentrate the microbes in the liquid. After concentration we can lyophilization. Lyophilization. Lyophilization means freeze drying. Freeze drying. That means after lyophilization, the bacteria, the liquid bacteria become powdery. Powder form, it created powder form because the drying created, that means all the water become evaporated and it is freezed. Okay, and that process is called lyophilization. After lyophilization, package, freeze, and store. But this storage could be 1 year also because you lyophilize the culture. But in the first case, just you package and freeze it into the low temperature. But that storage only for just for a week, 1 week or 2 weeks. This storage, the main process storage. So it is ready to use means it this starter culture should be used within 2 weeks. But if you did this type of process, that means lyophilization, if you done the lyophilization, you can store for the 1 or 2 year without any hampering. So that storage is for 1 to 2 year. But in the first scenario, that storage that is only freezing, it is for just 1 or 2 week. You have to be used within 1 or 2 week starter culture. And after lyophilization package freeze storage, you get lyophilized culture. Lyophilized culture. This lyophilized culture used in future purpose, not ready made. যে কোনো ইন্ডাস্ট্রি কি সবসময় ফার্মেন্টেশন চলছে না, তোমাকে তো ভাবতে হবে যে আমার একটা কিছু রেডি দরকার, জাস্ট উইদিন 1 উইক আমার একটা ফার্মেন্টেশন এক্সপেরিমেন্ট চলবে, তখন আমি কি করব, এটা বানিয়ে এই স্টেপ ফলো করব। বাট ইট নিডস ইন দ্য ফিউচার, দ্যাট মিনস 1 year বা 1 month, 2 months, 3 months later, then we use lyophilized culture. Production of starter culture clear, all of you?
Yes, sir.
Yes, sir.
Yes.
So today is the basics of starter culture in dairy fermentation. Next day class we are describing dairy starter culture particularly. It is overall starter culture description, types and what is starter culture, etc., and behind the history why the starter culture we shifted, because the previous two methods, back sloping and the indigenous microbes, could not fruitful to meet proper standard. So that's why you shifted towards the starter culture, pure culture, particular microbes, and the number of microbes that we control. Okay. So next day class, we are discussing about particularly the topic that is dairy based starter culture. Dairy based starter culture, and we are also start the making process also, manufacturing process. Manufacturing